Okay, and here we are in our brand new chapter, Chapter 7. In today's lesson, this first tutorial, we will look at solving right triangles using sohcahtoa. So we are in Chapter 7, the first section, 7.1, and we are looking at solving triangles. What I mean when I say solving triangles, I mean to find all 6 measures. That means that we're going to be finding all 3 side lengths and all three angle measures. Those are the 6 parts of the triangle. Throughout this entire chapter, please be sure that you are rounding to at least 3 decimal places. That is the standard, at least 3 decimal places. That is the third number past the decimal point. Please be sure that you're correctly rounding as well. And lastly, never round in the middle of your work. You've probably learned already in your science classes that if you round in the middle of your work, you're going to get some round off error, and that of course is no good. We want our answers to be as exact as possible. So please only round for your final answers. Do not use a rounded answer in the middle of your work. And I'll show you how to use your calculator to store the exact answers in the middle of your work if you don't already know that. So I've referenced sohcahtoa. Let's talk a little bit about that. Let's say we have a right triangle. There's our right angle. Depending on which acute angle you're standing on, I'll just put a little star right here suggesting that I'm standing right here because it all depends on where you're standing. Where you're standing, in relationship to that, we have what's called the opposite side. We have the adjacent side. And of course we have the hypotenuse, and that's regardless of where you're standing. The hypotenuse is always opposite the 90-degree angle. But since I'm standing on this acute angle of this triangle, I have my opposite side opposite that angle, and the adjacent side is the leg that I'm touching. So sohcahtoa is a simple memory trick to remember all 3 of our main trigonometric functions. So represents the sine function, and the sine function is going to be equal to, here, let me do this. Let's put an angle here, and I'll call it angle A. So we'll say that the sine of A is equal to the opposite, that's the O, divided by the hypotenuse, that's the H. So SOH for sine. Cosine, if I'm standing on angle A, the cosine is the adjacent divided by the hypotenuse, or CAH, there's the ka, and toa, that represents your tangent. The tangent of A is the opposite divided by the hypotenuse. Excuse me, opposite divided by the adjacent. That's the TOA. So that's what I mean when I say sohcahtoa. You might have learned other methods to remember your sine, your cosine, and your tangent when given a right triangle, but that's how I like to remember it. So let's look at our first example. We are meant to solve this triangle. So in this triangle, I've given you triangle A, B, C. I've actually already given you 3 pieces of information. I've given the fact that it's a right triangle, so this is 90 degrees, of course. I've given you one of the acute angles is 49 degrees, and I've given you one of the sides. Nothing else is labeled, at least the other 2 sides are not labeled. We have this missing angle. So let's first talk about how to label a picture correctly if the labels are not already there. If the labels are already there, if I've already put variables in the 3 spots where you're going to be finding the measures, then please just use those variables. If I have not, this is what you need to do. Opposite angle C is side C. It's a little c. Opposite angle B is side B, little b. and opposite angle A is side A. Now that's obviously already been given, so I'll just say A equals 7. So please understand that's how you label your missing parts. Opposite the angle is the same letter of the side. Sides are in lowercase, angles are in uppercase. Okay, the first thing I'm going to find is I'm going to find angle B, because that's really not that difficult. We know that the measure of angle B is going to be 90 degrees, take away the measure of angle A. And I already know the measure of angle A is 49 degrees, so the measure of angle B is 41 degrees. Please be sure that you have your degree symbol everywhere you're talking about an angle that's measured in degrees. So the three angles are now solved. I've got my 90 degrees, my 49 degrees, and of course now my 41 degrees. I'm missing side A and I'm missing side B. I'm going to be using my sohcahtoa ratios, but the question is, where are you standing on this triangle? You could be standing at either one of these acute angles, and it doesn't really matter, but I tend to stand on the angle that's been given to me. Just in case we happen to mess up to calculate this missing angle, just in case, I'm going to use the angle that's been given. And I'm going to put a little star or circle this part or draw a little person or something like that just to indicate this is where I'm standing, because I need to know where opposite and where adjacent is in relationship to this. Now, if I'm standing here, I have my opposite side. So if I'm talking about sohcahtoa, the two ratios that deal with the opposite side are the two ones that have an O, the so and the toa. So I know I'm going to be setting up a sine equation and I'm going to be setting up a tangent equation. So let's do both of them. The sine of the angle that I'm standing at, which is 49 degrees, is going to be equal to the opposite side, which is 7, divided by the hypotenuse, which I do not have. I'm calling that C. That's my first equation. The other one is going to be the tangent. So the tangent of the 49-degree angle where I'm standing is going to be equal to the opposite side, which is 7, divided by the adjacent side, which is B. And again, that's the unknown. These are the two equations that I need to solve. I'm going to solve these just like I would a proportion. I'm going to put this value over 1 so I can see my cross multiplication. I always like to start with the diagonal that has the variable, so that's going to be C times the sine of 49 degrees. And the other diagonal is what it will be equal to, which is of course 1 times 7, which is 7. So my variable is being multiplied by some number. I really don't know what this number is, but it is just a number. So I'm going to just divide that number away, just like I can do in any equation. Divide both sides by the same number, as long as it's not 0. And now I'll have C all by itself is equal to 7 divided by the sine of 49 degrees. I'm going to be plugging that into the calculator and getting an approximate value. So if you take your calculator out and turn it on should be your favorite button, because nothing will work unless you push on. Okay. The second favorite button is mode. We just came out of a chapter where we were bouncing around from radian mode to degree mode. In this chapter, we're basically going to be using degree mode every time. So please make sure you always check to be sure that your calculator is in degree mode. Go highlight that and press enter, and now we're good to go. We need to do 7 divided by the sine of 49 degrees. So I'm typing 7 divided by the sine of 49 degrees. The sine button opens up a parenthesis that I should of course close, and when I press enter I'm going to get an irrational number, and I'm rounding to the third decimal. So I've got 9.275. The fourth number is just a 0. That keeps the 5 as a 5. 9.275. Let's solve our second equation. I'm going to be doing it the same way. I'm going to make this a fraction equal to a fraction so that I can see my cross multiplication. I like to start with the diagonal that has the variable, so that's B times the tangent of 49 degrees, is equal to 7 times 1, and when I divide by this number, whatever this number is, divide both sides, I will have b is equal to this. When I plug that into the calculator, I should get 6.085. This time, of course, I'm using the tangent button. Close the parenthesis, and of course be sure you are in degree mode. We have just solved this triangle. I gave you 3 measures, and you solved for the other 3 measures. Let's turn over to our next example. This example is a little bit different because this time I've given you 2 side lengths, so you're missing only one side, but this time you don't have either one of the acute angles. You do, of course, know that it's a right triangle. The first thing I'm going to do is I'm going to label my missing sides. I've got side B, that's right up here. I've got side C, and that was already been given. Side A is the side that's missing. Obviously, angle B and angle A are missing, but those have already been labeled. So I'm missing side A, and I'm going to choose to find that first. I know that we are dealing with a right triangle, so I can just use Pythagorean theorem. I always start with the hypotenuse squared will be equal to one of the legs squared plus the other leg squared. So 14 squared equals 8 squared plus A squared. Let's go ahead and solve that. 14 squared is 196. 8 squared is 64. A squared, of course, is still a squared. If I subtract 64, and if I use the symmetric property, I like my variable to be over here. So if you don't mind, I'm going to write a squared first. That's going to be equal to 132. I don't want what a is. I want what, excuse me, I don't want what a squared is. I'd like what a is. So I'm going to take the square root to knock out the square, and I'm going to have a is equal to the square root of 132. Now this is not a simplified radical. I believe 4 goes in there, and I believe it goes in 33 times. Yep, that's correct. So if I want to use an equal sign, I would have to say a equals 2 square roots of 33. If you want to just approximate, that's fine. You can use your approximate symbol, and if you plug that into your calculator, you're going to have 11.489. I'm absolutely fine with either one of these, but please understand, if you're going to want to use an equal sign, you have to simplify your radical. Otherwise, just dump square root of 132 into your calculator and give me the approximate. Either one of those is fine, but please understand equals versus approximate. Okay, so now we're looking for either one of our acute angles, and that means that we need to pick where we want to stand on our triangle. I'm going to choose to stand right here. I give some indication that I'm standing here, whether it's a star or drawing a person or something like that. So I'm talking about side A, excuse me, angle A. In relationship to where I've just chosen to stand, I'm given my adjacent side and I'm given my hypotenuse. The ratio that compares adjacent to hypotenuse is your ka, or your cosine. So I know that I'm going to be setting up a cosine ratio, a cosine equation. The cosine of angle A is going to be equal to my adjacent side 8 divided by my hypotenuse 14. There's my equation. I need to solve for angle A here, or the measure of angle A really. So that means that this cosine needs to go away. Now, it doesn't make sense to divide a cosine symbol away. What we're going to do is we're going to be using inverse cosine. We're going to take the inverse cosine of this side and the inverse cosine of this side. The inverse cosine of the cosine cancels away. Now it's very important that you have the correct thing next. A is not what comes out. Angle A is not what comes out. It's the measure of angle A. You learn this in geometry when you're using an equal sign. You're using the measure of an angle. And my little angle, so that it doesn't look like a less than symbol, I put a little arc symbol in there. You might have a different symbol for angle, but the measure of angle A is going to be equal to the inverse cosine of 8/14. So let's get the calculator out. And we're going to be typing the inverse cosine. The inverse cosine is above the cosine button. It's in blue on my calculator, so I'm going to press the second button and then the cosine button. There's my inverse, indicated by the little -1. Inverse cosine of 8 divided by 14, and I'm going to close my parentheses, will give me this, and this is our angle. Again, let's round to 3 decimal places, 55.150. All right. So measure of angle A is approximately 55.150 degrees. Now we could do a different ratio to go and find angle B, or we could just understand that angle A and angle B are exactly complementary. They add up to 90 degrees. Or all three of these add up to 180 degrees, but I know if this is already half of that, then the other half is the 90 degrees. So I'm going to find measure of angle B pretty simply by just subtracting 90 degrees, and I'm going to subtract my measure of angle A that I just calculated. So the measure of angle B is going to be approximately 34.850. And I just did that on the calculator. So this one's a little bit different. We needed Pythagorean theorem to find the missing side, and then we set up and did an inverse cosine in this case to find one of the missing angles, and we subtracted from 90 degrees. That's the end of this tutorial. We're going to look at applications in our second tutorial. Thanks for watching. See ya.